Hello, I'm going to be doing the differentiation paper from the Selwyn College. And yeah, let's just get right into it. So, question 1, part A, is to differentiate this function y equals the cube root of cosine x. Well, this one I'm going to rewrite any root as a exponent. So I have this cosine x to the power of 1/3. And I can see that it's a function within a function, the inside function being the cosine x, and the outer function being the cube root function. So I'm going to use the chain rule here. So the derivative here is going to be the derivative of the outside function. So it's just multiplying it by the power, keeping the inside function the same, minus 1 from the power, so negative 2/3. And you have to multiply it by the derivative of the inside function. So that's minus sine x. And you don't need to simplify it, so I can just leave it like that. Okay, part B. Give the coordinates of the point on the curve f of x equals to ln of 2x squared minus x. So the coordinates of the point that has a gradient of 1. So at what point does this gradient equal to 1? So we need to find the derivative function first, or the gradient function. So we're going to derive this to get f prime of x is equal to 1 over 2x squared minus x. And then using the chain rule, I have to multiply it by the derivative of the inside function. So simplifying this, or just conjoining this together, you get 4x minus 1 over 2x squared minus x. Set this equal to 1, so I can solve for the x value here. So 4x minus 1, I'm going to multiply this to the right-hand side. So I get 2x squared minus x. Bring everything to one side. So then 4x becomes negative 4x, and then minus 1 again, negative 5x. And then get plus 1, and you can use your calculator to solve for the x values. So let's see. So polynomial degree 2, and your coefficients are 2, negative 5, and 1. And so your two answers are x equals 5 plus root 17 over 4, and then also x equals 5 minus root 17 over 4. And both of them are positive. So you don't have to worry about this ln function being negative, I don't think. So then you can then plug in both of these x values into the ln function to then solve for the y component of the coordinates. So you're going to go into your system here. So 5 plus root 17 over 4 is just that value there, but then you're going to use ln of that 2 times that answer squared, and then minus the answer. And so for the 5 plus root 17, your y value is then 2.095. And for the other one, it's going to be okay, so this one gives you a negative answer, so the negative in the ln, so this gives you negative 2.095i, so that's imaginary, so we're going to ignore this solution. And so the only solution that exists is going to be this one here. And that's our answer. Okay, part C. Part C is the distance of an object at time t seconds is given by this, so s of t is equal to t squared e to the negative t over 4, where t is between 0 and 40. Find an expression, so part 1, or part I of this question, is find an expression for the velocity. So distance to velocity, you just derive this function. But you can see that the displacement function is a product of two separate functions, the first function being t squared, and the second function being the e to the negative t over 4. So we are going to use the product rule here to find the velocity. So this is going to be the derivative of the first function, which is 2t times the second function, plus the first function times the derivative of the second function, which is negative 1 over 4 times e to the negative t over 4. So that's the velocity function, and that's it. You can tidy it up a little bit by factorizing out the e to the negative t to the negative 4. So this is e to the negative t over 4 times 2t, and then minus t squared over 4. Okay, and the second part is find when the velocity is increasing. So when the velocity is increasing means the change in the velocity is positive, and the change in velocity of the change in time is also known as the acceleration. So we need to find the acceleration formula and then set it to equal to 0 to then solve for when it's greater than 0. So then the acceleration is just the derivative of velocity. So again, product of two functions, right? So the first function being the e function, second function being the polynomial here. So derivative of the first function multiplied by the second function plus the first function times the derivative of the second function. 2t derives into 2. T squared over 4 becomes 2t over 4, which then reduces down to t over 2. And then what you're going to do is set this equal to 0, so you can solve for where the intercepts are for this function, and then see where the function is greater than 0. So let's see here. You can factorize out the e function again, and you're left with negative 1/4 of 2t minus t squared over 4 plus 2 minus t over 2 equals to 0. So you got two parts equal to 0. This e function equals 0, and this polynomial part equals to 0. So separate them out. E to the negative t over 4 equals 0. This solution doesn't exist because the e function never reaches 0. So you can ignore that solution. And the other part is negative 1/4 of 2t minus t squared over 4 plus 2 minus t over 2 equals to 0. Just expanding these brackets out, you'll get negative t over 2 plus t squared over 16 plus 2 minus t over 2 equals 0. All in all, t squared over 16, and then minus t, because there's two lots of negative t over 2, and then plus 2 equals to 0. And you can put this into your calculator now to find the solutions of t. So polynomial degree of 2, 1 over 16, and then negative 1, and then 2. So my two solutions are when t is equal to 8 plus 4 root 2, and then also when t is equal to 8 minus 4 root 2. And both of them are positive, and so greater than 0 and less than 40 here. So what does it actually look like in terms of a function? So what this looks like is a quadratic, because this is a quadratic graph here, or parabola. So it's going to look like this, with its two x-intercepts here, one at 8 minus 4 root 2, and the other at 8 plus 4 root 2. And this is the acceleration axis, and this is the time axis. This is the velocity axis. No, sorry, this is the change in velocity, also known as the acceleration, so dv over dt. So where is the change in velocity positive, or when is velocity increasing, which is here and here. So in both those regions, the acceleration is positive, which therefore means that velocity is increasing. So here, between 0 and 8 minus 4 root 2, that's the first region. And you need to bound it by 0 as well, because time cannot be less than 0 or negative. And then also when t is greater than 8 plus 4 root 2. So those are your two time frames of which the velocity is increasing. Those are your answers. Okay, on to part D. For the function y equals 1 over x, show that dy over dx is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Gives the derivative. I don't think you've actually been taught how to do first principles in level 3, and I don't think it's a requirement, but we'll go through it anyway. So basically, the f of x function is just your y function, 1 over x, and then f of x plus h is going to be wherever you see an x, you replace it with an x plus h instead. And then using this derivative function, the limit as h approaches to 0 f of x plus h is 1 over x plus h, and then minus 1 over x over h. And you're going to wonder to yourself, what is this limit function for? Well, as h approaches to 0, eventually you have to substitute in h is equal to 0 into this expression here. But you can't do it immediately because you have h as the denominator of this fraction. You can't divide anything by 0. That's not possible. And so you need to somehow factorize out an h at the numerator to then cancel out h in the denominator, and then you can let h equals to 0. So what does this look like? So at the top, you obviously need to combine the two fractions together. So you're going to cross multiply. So multiplying the right one by x plus h over x plus h, and then the left side by x over x. So you're left with the limit as h approaches to 0 of x minus x plus h over x times x plus h over h. So then this becomes, again, the limit as h approaches to 0. X minus x is just 0, and then minus h, it's minus h over x times x plus h, all over h. And again, you can rewrite this as negative h over x times x plus h divided by h, which is then rewritten as negative h over x times x plus h times 1 over h. So essentially the h's, they cancel each other out, which is exactly what we're looking for. So this reduces down to the limit as h approaches to 0 of negative 1 over x times x plus h. So then you can let h equals 1 to satisfy the limit. So negative 1 over x times x plus 0 is just x times x is x squared. And that is the derivative using first principles. Yeah, that's it.